Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul AIDA BINTI RASHID from AS2294A. So today I'm going to present about Module 3, Spatial and Geostatistical Analysis. Objective for this lab is able to create buffer and overlay of spatial data, able to merge two or more features classes into single dataset, and able to apply spatial analysis tools.
Drag the ref to table of content. Go to Geoprocessing and click Art Toolbox. Click Proximity and click Buffer. Input features, click deref, and for output features, rename it as deref buffer 300.hsp. Set linear unit 300, dissolve type all, and click OK. Wait until it done buffering. This is the result of buffer all. Redo the step again and leave the dissolve type to none. Output features, name it as deref buffer 300 none. This is the result of buffer none. Next, drag district Kelantan to table of content. Then, click overlay and pick erase. Input features, click deref buffer 300. Erase features, click deref. Output features, name as deref erase. And then click next and click OK. So this is the result for erase. Next, under overlay, click union. For input features, click district Kelantan and deref buffer 300. For output features, name it as deref district union and click next and click OK. This is the result of union. And right click on district Kelantan and open attribute table. Next, go to deref and right click and open attribute table. Next, click intersect and input features, click deref and district Kelantan and click OK. So this is the result of intersect. Go to deref intersect and right click and open attribute table. There are 343 records in final HHP. Next is geostatistical analysis. Drag the arrow to table of content. Open Art Toolbox, click Conversion Tool, click Add Cell and Add Cell to Table. For input, click Data Ground July and click Open and then click OK. This step is important to import Excel data into ArcMap. Next, right-click Table Data Ground to display data point, and for X field, click E. For Y field, click N and click OK. Right-click Point Data and click Data and click Export Data. Name it as PM Temp and save as shapefile and save and click OK. Go to Customize extension and check the Geostatistical Analysis box and click Close. Next, click Customize toolbar and click Geostatistical Analysis. Click Geostatistical Analysis, Geostatistical Wizard to create interpolation of PM10. Click Inverse Distance Weighting, set data set to temp PM10 and click Next, Next and Finish. Right-click Layers Data Frame, click Properties and click Data Frame tab. Click Others, specify Extend, outline features, click Daerah and click OK. For clip option, click to shape, click Specify and click Outline features and click Daerah and click OK. Right-click IDW layer, click Properties, click Extend and pick the rectangular of Daerah and click OK. Click the first icon on table of content to rearrange all files in the table of content. Right-click PM10, click Properties and tick Label Features and click OK. Arrange the daerah file under PM10 and change the color to hollow. Next, click Geostatistical Analysis, pick Region under Geostatistical Method, click Data Field, pick PM10, click Next and pick Region Type Ordinary, click Next, Next and Finish. Next, right-click Region, click Properties, click Extend and set Extend to the rectangular extent of the daerah and click OK. Rearrange the PM10 file on top of table of content.
The next part is practical highlight. Practical highlight have two parts, which is spatial analysis and geostatistical analysis. For the first part of practical highlight, which is spatial analysis, the first question about discuss how do the result differ between dissolve all and dissolve none in buffering, and when would this be important. For dissolve all the buffer together into a single features and remove any overlap. And if you want to remove the border of geographic, we can use dissolve all. And it's mainly for generalization and always simplify boundaries from a more complex one. In a simple word, it melts the boundary into one. And dissolve all also more generalization. It's important when we want to create continent, you can erase all country borders, and it also simplify the boundaries. For dissolve none, it individual buffer for each features is maintained regardless of overlap in the map, and it have left generalization. It's important when you want to create country borders. Okay, for the second question, screen capture each overlay analysis done and explain the overlay features. For the first features is erase. Remove the area that is overlapping with erasing features, and the input layer is the features that will be erased. For example, remove all burned down tree stand. For the next features is union. Combine input data layer into a single composite layer. Non-overlapping part also get passed into the output as well. Can only be used with polygon features. For example, combine the state with river. For intersect, use to select any part of the features that intersect with one or more other features. All the features that overlap, intersecting layer will be point of the output future class. The example is intersection of river and drain line flow. The third question is how is the XY tolerance defined in the intersect dialog, and how many record does final SHP? The SY tolerance is the smaller distance between coordinates before they are regarded, and it can be set to a different value if the default is not acceptable. The final SHP contains 343 records. And the fourth question is highlight all spatial analysis performed in this practical and relate the function of each analysis with real application in environmental context. For the first one, buffering, reclassification based on distance, involve measuring distance outward in direction from an object, and it can be used to point a line and area, and the outcome is a polygon file. For example, a case study of school children in Orange County, Florida, used a buffering to identify the exposure potential air pollution for school children by determining the distance of school location to gasoline stations, stationary pollution, and industrial facility. And for overlay, overlay is superimpose numerous datasets to detect link between them. We use erase, union, and intersect for this practical. By integrating the geometry and properties of the incoming dataset, an overlay will create a composite map. Example for overlay, a case study of lack of conventional freshwater resource in Egypt. They use overlay to find the best location for artificial recharge of groundwater area, which was at Sadat Industrial City. Okay, for the next part of practical highlight is geostatistical analysis. The first question is, you have tried several types of interpolation method. Screen capture the output and explain based on your observation the difference between all the methods. The first one is inverse distance weighting. It determines all cell value using linearly weighted combination of sample point. And with its function, it's assumed that near value are more connected than further value, and it a flexible spatial interpolation method because you can set your inverse distance weighting interpolation in different way, and you can set up a barrier. And for creasing, a spatial correlation can be used to explain variation of the surface by measuring the distance or direction between sample points. Include exploratory statistical analysis of data, variogram modeling, creating the surface, and most appropriate when there is spatially correlated distance or directional bias in data, and it uses mathematical and statistical data. And for inverse distance weighting, it uses mathematical data. Okay, for the next question is summarize the use of geostatistical analysis used in this practical in environmental study. For inverse distance weighting, is an interpolation estimate unknown value with specifying search distance, closet point, and power setting and barrier. Is a type of the deterministic method. The closer a point to a approximated cell center, the greater its influence on the averaging process. The example, inverse distance weighting was used to develop air quality index prediction based on some meteorological parameter collected. The study was conducted in Kuala Lumpur. And for quizzing, it can be used to describe a model spatial pattern, predict value at unmeasured location, and assess the uncertainty associated with predicted value at the unmeasured location. It's a type of geostatistical method, and the quality of which reflect the quality of the predicted surface. And for the example, a researcher used a quizzing technique to estimate groundwater quality of the study area, poses various problems due to the impact of cultivation and urbanization. In conclusion, I was able to create buffer and overlay spatial data. I was able to merge two or more features into single dataset, and I was able to apply spatial analysis tool. Spatial and geostatistical analysis are very important to be learned as it can help us to make prediction in environment field. That's all from me. Thank you.